All right, we are going to go over graphing this, and there might be a little bit of uniqueness with the denominators this time. We might not have a common denominator. It might not work out as nicely as it did in other examples, so we'll have to pay good attention to that. All right, let's graph this. We are graphing a sine wave, and it has a negative in front. That already tells me that the shape of my graph will go from a 0 down to a minimum, back up to a 0. And again, I'm using the word 0, but it might not be an x-intercept because you're going to move it up and down 5 units. So really, it's on your sinusoidal, down, because it's negative. Usually sine goes like this, whoop, right? Back up to the sinusoidal, a max, and back down. So I like to draw this part first, and I can draw my smiley face and my frowny face. There we go. We can put a little extra tail there, a little extra tail there, and that tells us, kind of curling it, that this wave goes forever and ever and ever, okay? Next thing that I'm gonna take care of, so far, the only thing that I addressed was the sine and the negative. Next thing I'm gonna deal with are the 5 and the 2, so we'll start there. 5. The 5 is this line right here. It is the middle of my graph. Normally the middle of your graph is on the x-axis, but it's like I grabbed it here and was like up 5 and put it down somewhere new. So that's at 5. So this is the sinusoidal axis. Sinusoidal axis is at y equals 5. And the 2 tells me that the distance from there all the way to there is 2 units, and there to there is also 2 units. So that means if this is 5, that's 2 units bigger. So I know I'm not really writing, I'm just putting a little note on the side. That's going to be up at 7, and I know that that's going to be over here 2 units lower at 3. Now that I have some numbers, right, 3, this is 5, and 7, then I know my x-axis is a little bit lower. It's somewhere down over here. So it makes my drawing a little bit better. This way I know I fit it nicely. So I'm just going to go here. Whee! There's my x-axis. Beautiful. All right. It doesn't have to be perfect to scale. It doesn't matter. Then I'm going to go here. I'm going to put a tick mark underneath each of these dots. We have 5 dots. So we have 5 tick marks. So I'll have 1, 2, 3, 4, and 5. Now, there's my tick marks. What about those? What can I, so we dealt with all these things. Now, which one can I label pretty easily? This one, x minus 2 pi over 9. That moved your graph to the right 2 pi over 9. All the examples are actually much, much easier when you move to the right. The reason that they're easier when you move to the right is because all of your tick marks are going to be positive if you just keep moving that way. That means that your y-axis you could just draw somewhere over here, and you don't have to wonder like where your y-axis is going to be. It's more complicated if you went plus than you went left. Well, I don't know. Is my whole graph going to be on the left of my y-axis? Or maybe it's going to start there and cross over and come to the positive, and where is it going to be? So we wait. We draw our y-axis after we know. Well, now that I have my y-axis, I could put 3, 5, and 7 on there. So here's 3. This one is 5 and 7. I don't need 100 tick marks. Just put the important ones. Don't get it too crowded. It's too annoying to do that. So y-axis is labeled 2 pi over 9. So that's dealt with. The last piece is dealing with the b value. Normally, this will be in length. It'll be 2 pi in length. And then I would divide 2 pi by 4 to figure out, sorry, let me shut that off. So 2 pi, I would divide it by 4 to figure out how big a quarter is. And that's going to tell me how big all those spaces are, and I'll keep adding. But this has a 3 right here, and that means you have a horizontal compression by a factor of 1/3. So we're squeezing this graph together so it's 1/3 of the size. So normally, I'm going upward, but normally if you have a graph like this for sine, if you had a compression of 3, well, now you have 1, 2, well, I'm not barely fitting it, 3. You'll have 3 graphs squeezed in because it's 1/3 of the size. That's why there's a 3 there, just so we understand that that is the frequency, okay? It's how frequent you'll see that graph in the typical window of time. Anyhow, our period formula is 2 pi over b, and the b is the 3. So the period, that means the distance from the very beginning of our graph straight through all the way to here, that length is 2 pi over 3. Okay, great. What do I do with that? I'd rather find now the quarter period. That's going to be 1/4 of the period. Okay, so let's do that. 1/4 of 2 pi over 3, and that becomes 2 pi over 12. Now, maybe I should reduce it, maybe not. I always wait and check. That's a 12, that's a 9. Ugh, those are annoying numbers, but it'll be a little easier if I just reduce this fraction first. So let's reduce it. Quarter can equal then pi over 6. Now, how the heck am I supposed to add pi over 6 over and over right now? I don't have a common denominator. So I need a common denominator between that number, quarter being pi over 6, and that number, 2 pi over 9. So what is the least common denominator between 9 and 6? Well, it's not 6, just because you hear the word least. It doesn't mean smallest. What it means is, if we have, just a little note here, 6 is one denominator and 9 is the other. But 6 is really 3 times 2, and 9 is really 3 times 3. So let's say you have twin daughters, Gisbel and Lisbel, and Gisbel has a 3 and a 2, and Lisbel has a 3 and a 3, and now they're fighting and crying and driving the parents crazy because Lisbel is upset because she wants a 2. Gisbel has a 2. Why can't I have a 2? And then Gisbel's crying because Lisbel has 2 3s and she only has 1 3. And you're dealing with your crying daughters and you're just like, oh my gosh, kids, stop. So you're going to go here, multiply top and bottom by 2. So now Lisbel has a 3, and a 2. Gisbel's still crying. Hold on, I'm coming. Multiply on top and bottom by 3. Now she has a 3, and a 2 as well. And now they're done crying. So what do they have on bottom now? They don't have 6 and 9 anymore. They have the same number. What is it? 3 times 2 times 3. The new number on bottom will be 18. Now they're 18 years old and they stopped crying. Amazing. They don't fight anymore. So that's what you need to do. So this pi over 6, I'm going to multiply it on top and bottom by 3. And that gives me 3 pi over 18. I don't know what that is, sorry. Oh, that was the 7 from before. 3 pi over 18 for the Q, quarter period. And then this, I'll multiply on top and bottom by 2. So the new starting point, I'm just going to change it and write 4 pi over 18 instead. And then we just add 3 pi over 18 over and over until we get to the end. 4 plus 3, so we'll have 7 pi over 18. 3 more, we get 10 pi over 18. You don't need to reduce these. Just leave it. It's better this way. Oh, and I have the wrong header on top of my video the whole time, huh? What a shame. Title. This is graphing sine with transformations. I hate when I do that. Oops. Well, what are you going to do? All right, so 3 more, we get 13 pi over 18. 3 more, and we get 16 pi over 18. If you wanted to check, a good way to check is how far apart are 4 pi over 18 and 16 pi over 18. That will be 12 pi over 18. So if I subtract the last 16 pi over 18 minus first 4 pi over 18, you get 12 pi over 18. We're going to reduce that a little bit 12 and 18, they both reduce by what? 6. And I get 2 pi over 3. Well, that should equal the period. And it does. Winner, winner, chicken dinner. We are good to go. And that is the end of the example. So I hope it makes sense. I'm sorry if the title on top saying systems of linear and quadratic equations was confusing to anybody, but hopefully that was helpful. If you're still confused, just stick a thumbs down on the video. If you understand now, put a thumbs up on the video, and we should be good to go, especially when it comes to that common denominator step. So do we have any questions before I end the video that you think are important, or are you good?
Very good.
You're good? All right, nice. So have a nice day.